pay your attention over here. Okay, so this one is the one new method named Gauss-Jordan method. Same PDF I have uploaded onto the Moodle so that you can check out at the end of this lecture. Okay, so over here what you have to do in Gauss-Jordan method. So if you have to find out the inverse with the help of this matrix, then what you have to do? A matrix which is given to you, right? Now what we have to do? We have to just write down this matrix with the help of this identity matrix in the augmented form, right? So how to write down this augmented matrix? So A, and in B part you have to insert this identity matrix, right? Now what you have to do is for this Gauss-Jordan method, this first matrix, whichever is given to you in a question, that you have to turn into the identity matrix, right? So obviously, if you will perform any operation with this matrix, it will reflect to this identity matrix. So nothing but you have to just set these two things. Now how to do? So what you have to do? You have to make this first matrix, right? Okay, into the identity matrix. That if you want to make this matrix as identity matrix, and whatever operations that you are performing over here, the same thing reflected over here, right? And by doing that, you will get this new matrix, right? And that new matrix is your final answer. Okay, so this one is a very simple method. You don't have to do any extra thing. What you have to do, you have to just do the row manipulation operations, right? So suppose this one is my A matrix. If I want to make this matrix as identity matrix, then first of all, what I have to do? I have to check it out. Say how many rows in this matrix contains the zero element, right? So am I audible? My voice is clear? Or any disturbance? Okay. Okay. So over here, just check it out. Two elements are equal to 0 in the second row and in the third row. Okay. So what we have to do? We want to make this is equal to 0, right? Because in this two values is equal to 1, which is the identity matrix, right? So what are we doing? We are just multiplying this first row by -2 and adding to the second row. And by doing this operation, we got this first element is equal to 0, right? And with that operation, just check it out in the second part, which is also reflected, right? Now in the third part over here, what you have to do? Now you can swap this first and second and third row, right? So what I have done, I have just interchanged this second row with this third row. And by doing that, what happened? This one is my new matrix, right? So now what I want to, what I have done, divided this second row by -2 because I want this one is equal to 1, right? So what we have done, we have just divided this second row by -2. And by doing that, we got this new matrix. Now just check it out. This 2 is equal to 1. This 2 is equal to 0. I have to make this -2 is equal to 1. And this remaining 3 element is equal to 0. Right? This one is my task. Now how to do this thing? So over here, we are doing two operations. First one, addition of this first and the second row. Right? And by doing that, we got these values. And -5 times the second row to the third row. So by doing that, how many elements that we got is equal to 0? 4 elements, right? And this 2 becomes the 1. Now what I have to do? I have to just take care about this third row column, right? And how to do this thing? So just multiplying each and every element by 2 and adding, right? So what are we doing? We are just multiplying the third row by 2. So by doing that, we got this 1. Okay. Now what are we doing? We are multiplying the third row by 1 by 2 and adding with this second row, right? So we got this 0 and this 0. So now just check it out. My first matrix became the identity matrix and my second matrix got some another values, right? So this inverse part is my new values, right? Okay. So what we have to do? We have to just do the simple mathematical operations over here on each row to make this first part of the matrix equal to identity matrix, right? So this one is the very simple. You don't need to mug up anything. What you have to do, just write down the matrix in terms of this, okay, augmented matrix. The first matrix that you have to write down as it is. In second part, you have to just write down the identity matrix, right? Now, after performing the mathematical operations on this each row, what we have to do, we have to just convert this first part into this identity matrix, right? And the second part that we got is our answer of this Gauss-Jordan method. Okay, so it is clear how to do this Gauss-Jordan method? Yeah, ma'am, it will be heat and trial method. It means I'm not getting your question. Rishabh, I'm not getting you. What are you trying to tell me? Okay, now how to check whichever answer that you got as the inverse of this matrix is equal to right or wrong, right? So for that, what you have to do, you have to just do the multiplication of this inverse matrix with your original matrix, that is A. Okay, and if you will get answer is equal to identity matrix, then you can say that your answer is the correct one. Okay. So whenever you will work with this matrix inversion and whatever answer that you got in the final steps, final calculation, that you have to multiply with your original matrix, right? And by doing that operation, whatever matrix that is you will get it is in terms of the identity matrix, right? And if it is in identity matrix, then you can say that your answer is the correct one. Otherwise, not. In our direct methods in Gauss elimination and LU decomposition, what are we doing? We are just doing the back substitution, right? And by doing that, we will confirm the answers. In the same way over here, we have to do this multiplication. And with the help of that, we can say that our answer is right or wrong. Okay? Are you getting me? Is it clear or any questions? It is a very simple thing, right? And simple mathematical operations that you have to perform on each row to make it as a either you can do the row swapping or you can do the addition, subtraction or multiplication, division. But when you will implement the same method in terms of the programming, at that time what you have to do, you have to keep in mind two things: space complexity and the time complexity. Now, for the time complexity, what we have to do? We have to use the minimum number of for loops along with the matrix multiplication and division operations. Okay, because if we perform maximum number of division and the multiplication operations, then obviously your time complexity should be increases, right? So, what we have to do? We have to keep in mind all these things whenever we'll do the programming for such a kind of methods, right? So only these things that you have to keep in mind when you will do the programming related to these theories. So up to this, are you clear? Now after that, only one theory related to the iterative methods or the indirect methods is remaining for this unit, right? So that will complete in our next week lectures. Okay. Now on this weekend, I will share some 5 to 6 examples related to the theories that we had covered during this week, right? That you have to upload in the next weekend, next to next weekend, right? So around 10 days time would be there. Okay. Are you clear? Fine. Up to this, is there any question, any doubt, any query in any of the theories? Because I can understand it is a little bit difficult for you also to, to learn this mathematical kind of subjects in this way, right? And for me also, it's a little bit difficult to convey the things. But still, I'm trying my best to do the things. If you will have any questions, any doubt, any queries, you can ask me at any time, right? Okay, fine. So I'll stop my screen over here.